Hey guys, what's up? My name is Gabe and this is Games with Gabe, and this is the next episode in the Coding a 2D Game Engine in Java series. So in this episode we will finally be getting to the point where we have Box2D fully quote unquote integrated, and we can actually create physics bodies and play and stop our scene like this. Now to get this done we have three big things left that we have to do. First thing, we need to fix the rotation so that it rotates about the center of an object instead of what we currently have it where it's rotating about this corner. Second, we have to add support for enums in our Box2D code. So right now we have an enum here, but we can't switch it because ImGui, the code we have written for ImGui, doesn't know how to handle the enum. So we will add support for that. And lastly, you'll notice that the scale on this object is very small. So the scale is 1.05, whereas before we had it at 32. We'll be resizing the projection matrix and the camera's viewport to be a much smaller viewport because Box2D works best if you model after real world units in meters. So that means that if we have a box that is 0.25 meters, it should be reflected in the scale, and that will make it behave more realistically, like better physics in general. If you have it too big, then it can get weird, and if you have it too small, it can get weird. So we're just gonna be resizing it so we can have better units to work with. Okay. So let's take a look at how all this is going to work, and then we'll go ahead and implement it. Alright, so like I said, we have three big things that we're going to be doing in this episode to get our project to the state that I showed in the beginning. The first thing is we have to resize our projection matrix. Right now, the way we have our projection matrix sized, it's more like it's 1920 by 1080. So this is like 1920 fragments. I'm not going to say pixels because technically it's fragments. And this is 1080 fragments. And what we're going to do is resize it so that this is now 6 fragments and this is 3. This way it'll be more like the camera has a viewport width of 6 meters by 3 meters. And in the future, we'll probably make this customizable so that if you place a camera in the scene, you can decide how wide and how tall you want that camera to be. Okay, so that's pretty simple. We're just going to change the projection matrix. We'll have to fix a few other things to get the grid lines to work properly and stuff like that, because now they'll be different than going 32 by 32. Second thing that we will be fixing is enums, right? So if we put an enum inside of some sort of script, like say you have a player script and that player script has an enum called state, and that state enum has value 1, value 2, value 3, etc. Well, if you want that to be choosable at runtime in the editor, right now it's just not going to show up because in our ImGui function for components, we don't have a way to deal with enums. So what we can do is we can check and see if we have a value that is an enum using Java reflection, and then we can even iterate through each of the values, display them inside of the ImGui window, and then we can allow you to choose them by choosing a specific value. And so we'll take a look at how to do all of that and write the code in ImGui to get this working, which is a pretty cool feature to have. And then when the player has some sort of script that has a state enum, it'll just automatically detect the different values and stuff. Pretty cool. And then lastly, what we have to do is we have to fix the rotation. So right now we have it so that if you were to rotate any cube, it would sort of rotate about this axis, and then it would be like over here now if that was the same cube, if we were to rotate it. But what we want to happen is we want it to be rotating about the center, just because it makes more sense to rotate something about the center. And once again, this might be customizable in the future, but for now, we should have it rotate about the center because that's more intuitive. To get that to work, inside of our batched render, what we currently have is we have these values where it's like 1.0. So we go like 0.0, 1.0, 1.0, 1.0, etc., etc. And this basically says, hey, add this to whatever vertex. So if you specify this position, then this will be the bottom left corner of whatever object you're drawing here. Whereas we want you to specify this position, and then the vertices go halfway across to each of those. So instead of using 0 to 1, we'll just use negative 0.5 to 0.5 in our batched render, and that should fix the issue of it showing up in the wrong sort of way. Okay, let's get started with the camera projection, and then we'll get all this stuff working. All right, guys, so first things first, let's fix our camera's projection matrix. So if we go into here, into our project, okay, and then when we go to camera, then we can go ahead and just fix this. So instead of going 32 times 40, 32 times 21, we want this to be 6 by 3. All right, and we'll actually parameterize this too, just so that we know that this is parameter. We'll say private float projection width equals 6, private float projection height equals 3, and then we'll just copy and paste this into here and copy and paste this into here. Alright, so now our projection should be fixed. If we hit Shift F10 and go back in, you'll notice we don't see any grid lines or anything. Why is that? That's because our projection has shrunk. So to fix that, if we go into grid lines, we can see that basically what we're doing is we get the grid width and we want to change this width because right now it's 32, which is way too big. So if we change this to 0.25f, which I found out is like fairly reasonable width and height, and then change this to float, we can change the grid size. And if we go back into grid lines, this is going to create some problems. We just change these to floats and this will fix all of these issues. So just change all of these types to float and that should be fine. Then if we run this again, we get our grid lines back. But when we drag and drop an object, this is huge. Okay, so this is the object, but it's huge compared to our projection. So we want to fix the scaling now. And the way to do that is if we go into prefabs, we can see this is where we're actually creating that object. And we can see that we set the size to whatever size, and it's using this function. Now, to find out where this function is being called, because it takes a size X and size Y, we can just right-click the function and say find usages. Then we'll go into here, and we will go ahead and change this. So instead of doing 32 by 32, we'll do 0.25f by 0.25f. Now that should fix the sprite object, which if we click this, okay, it is normal size now, but the gizmos are super huge. So if we actually look at that find references function, it also said the gizmos weren't right. So if we go to gizmos class, then up here we have the width and the height and everything, and actually copy the width right now and paste it over here because for some reason we never had it using the actual width and height from up here. Anyways, that will get the correct width and height, and I found that if we divide by 80, it gives us some good estimates of how to shrink this. So if we change this to over 80f as well, and then if we just change these to floats instead, then that should be good, and we now have a good size gizmo. But we're going to also have to change the offsets because these are messed up now too. And I found out that 24 over 80 and minus 6 over 80 was good for this one. And then for this one I found out that minus 7 over 80 and 21 over 80 was good for this one. And this isn't going to look right immediately. That's because we still have to fix the batch render. So if we drop this in, they look kind of weird. This does not look right at all. And that's because of the next thing, which I said, we basically want them to rotate about the center, which was the next phase inside of the things we have to fix, right? We want it to rotate about the center instead of the bottom left corner. So if we go into render batch, we can fix this real quick just by going down to our load vertex properties function. And you can see that this is where we have the xat equals 1, 1, and then 0, and we're using those. We can just change this to 0.5 instead, and this will basically place things about their center instead of placing them by the lower left-hand corner. So if we change this to 0.5 and minus 0.5, and this one to 0.5, then we load this back in. The gizmos should look fine now. So if we hit the gizmos, they look fine, but their bounding boxes are off, and that's because now we're placing them about the center instead of placing them about this left-hand corner. So if we go back into gizmos, where we have the check X hover state and check Y hover state, we can just fix this by adding in half the width. So if we go ahead and say plus gizmo height over 2.0f, and then we subtract half of the gizmo height, and we just do this for everything, then we should be good. So we'll say minus half of the gizmo height over 2.0f. We'll copy that, paste it over this. Wait, nope, this should be gizmo width. So make sure that's gizmo width, and then if we copy that and we paste it over this guy, then we should be good. And then if we copy this, paste it right here, and we'll say this should be minus, then that should be good as well. And then we do the same thing for the check Y hover state. So this should be plus gizmo width over 2.0f, and then just copy that, paste it over here, and this will now be minus. Nope, I'm sorry, this is still plus, so then this will be plus. And this should actually be gizmo height. And then we can copy that, and we can paste this over this, copy this, paste it over this one right here. Okay, there you go. So now that should fix the bounding boxes of what we're checking. So if we drop in an object, click it, you'll notice that the bounding boxes look like they are fitting it appropriately now. So that's good. This is working fine now. And you can take a look at these, pause it right here if you want to take a look at those. Now the next thing we want to fix is inside of the components, because right now if we were to drop an object into here, and notice also how it's going about the center, so it's not lining up with the grids perfectly, and that's because we are placing it according to the center now instead of according to the bottom left, which is good. But anyways, if we go into here and we hit add rigid body, you'll notice there's no drop down for, if we go into rigid body, for the body type, which we do want there to be a drop down for that, because that's the best way to represent this. So to fix that, if we go into component, we just need to add in a else if inside of our big component ImGui function. We just need to add in something for enums. So if we say else if type dot is enum, which Java conveniently gives us, and then we can say string, then we'll say enum values equals get enum values type. This will basically get each of those enum values as a type. So if you have an enum and it has like value 1, value 2, ... basically it will return these values as strings, and we can do that using reflection, and we'll create that function in just one moment. And then we'll say string enum type equals enum, we want to cast it to an enum value.name. Basically what this does is it converts whatever the enum's actual name is to a string so that we can use it right here. And then we'll say ImInt index equals new ImInt index of, which is another function we will create, enum type, enum values, and this will basically get what the index of this type is, this string within this string array, which will give us all the information we need to then say if ImGui.combo, and we want to use the enum, whatever this field's name is, so field.getName, and then we want to say index, because if we look at this, this says, okay, what's the current item? The current item is index, and then the items are the enum values, and then we want to say enum values.length for the index count. So if that is true, so if they changed it, then we say field.set this to type.getEnum constants index.get. And basically, if you control click on this, this says that it gets you an object array, which is basically the enum, and it gets you an array of all the enum values. So we basically set the enum to whatever its appropriate index is inside of this enum array. Okay? A little bit confusing, but I promise it's not that bad. If you take a look at the code a little bit deeper, you should be able to get this pretty easily. Now let's create this getEnumValues function. So if we scroll down, right above the destroy method, we will go ahead and say private t extends enum t string array. So this is going to return a string array, getEnumValues. And we want to say class t enum type. So this looks very complicated, but it's really not that bad. We're basically saying type t is a type that extends enum. So we're saying this type needs to be an enum. It needs to be an enum, okay? That's what we're saying. And then we want to say we're getting a class that is this type. So this restricts this function to only be able to be used if the type is actually an enum, which is good. So if you try and use this function with something that's not an enum, it will throw an error. This also gives us useful hinting information. So then we can say string enum values equals a new string enum type dot get enum constants dot length. And we can get the enum constants off this type because we know for sure it is an enum. Then we'll say int I equals 0 for t enum integer value of enum type dot get enum constants. So we're going to loop through each of the enums as integer values in the enum constants. Technically they're objects, but it is what it is. We'll say enum values I equals enum integer value dot name. And this will do the same thing that we did up here, which basically just gets the name, so the actual value, the variable that you named it, okay? And then we'll say I++. Then return enum values. All right, and then the second function is much simpler than that one. Private int index of string str inside of a string array. And this will just loop through. We'll say for int I equals 0 until I is less than array.length I++. Then if string.equals array I, return I. Otherwise we return -1. So we just loop through the array, and then if we find something that matches the string that they passed in, then we return that index. Otherwise we return -1. Very simple, nothing too complicated there. And now this should add support for enums. So if we compile this and run, and we add a rigid body, we can now get the body type. So it says body type, which is what we call the variable, and we can change it to the different enums. And this is all generated automatically. So to illustrate just how cool this is, let's go into rigid body again. If we click on body type and then we add in something new here, a new value, then we recompile, you'll notice that if we add this in and we click it, add rigid body, we get a new value down here, just dropped into that dropdown. Super cool stuff. This is why reflection is so awesome, and we can use it to do very cool things. All right, cool. So now that works. One thing we need to fix also, if we drop in an object here and we try to change the transform's rotation, it doesn't do anything. Why doesn't it do anything? Because I was stupid when I created the transform class and forgot that this returns a float and this returns an int. So we need to say this dot rotation equals that, and we need to say this dot ZIndex equals that. Now if we run this again, that should be fine. So if we run and change the rotation, we can rotate it. Also, notice how it is rotating about the center of the object. That is very cool. We can rotate things about the center. Right now, we're at a really good place. If we add a box collider to this and then actually set this to like 0.25, set this to 0.25, and then if we go ahead and give it a rigid body and just leave everything as is, then we add in another object down here. We'll say give it a rigid body and a box collider. Change this box collider also to 0.25, 0.25, not 0.14. And then if we just make this one static, static means this one won't move, dynamic means this one does move, and then let's give this one some mass. If we hit play, it works. We have physics, look at that. That is very cool if you ask me. If we move this over and hit play, it bounces off the object like it should. Cool. So we've basically got physics working. Now, what would be nice is if we could hit Control D and duplicate this, because right now, in order to add in a whole new object, you actually have to drag this in, change everything over here, and that's quite annoying. So let's add in an option to duplicate very quickly. If we just go into Gizmo, and the reason we're putting this in Gizmo for now is because it has this whole active game object. I do want to switch this in the future. I don't like the way that this was done initially, but for now, this is how we're going to do this. We'll just add in a key binding. We'll say if key listener is key pressed, and then we'll say GILIF W key left control, and then I'm going to move to a new line. Key listener dot key begin press, and this is a function we will add GILIF W key D, and then let's import that. So what is key begin press? Well, basically this just means if they press this, we'll trigger this the very first time, but if they hold the key down, it will not return true. So this will return true for the first frame where this is pressed, and then every frame thereafter it will return false. How do we implement this? Well, let's go into key listener. If we just go ahead and create a new Boolean array up here, key begin press equals a new Boolean, and we'll make it the same size, 350. And then if we go ahead and just go down here and say get.key begin press key equals true when we press it, and then get.key begin press key equals false when it's released. This will basically just set this value to true the very first frame that this is hit, and then it'll set it to false whenever it's released. It won't set it to true if the key is being held down. Then we'll create a new function. We'll say public static boolean key begin press int key code. Then we'll say boolean result equals key begin press. Well, we have to say get dot key begin press key code. And we'll say if result is true, then we want to just set it to false. Then we'll say get dot key begin press key code equals false, and then we'll return the result. What's happening here is we're basically just saying, okay, if they query this and then it turns out to be true, and then we're just going to set it to false. This could pose problems for, like, if multiple people ask for the same key, then this technically won't work correctly. We'll fix that in the future, but for now, this works as it should, and we'll look into fixing that in the future. Okay, let's go back into Gizmo to get this working now. So if the key is begin press, all that stuff, then we should be good. And then what we're going to do is we're going to say game object new object equals this dot active game object dot copy, which we will create. And I'm also going to put a to do in here too because I don't like this. We'll say right down here to do move this into its own key editor binding component class, because that's where this stuff should be. This shouldn't be stuck in with gizmos, but we'll have to fix that later. So we're going to copy the object, and we'll say window.getScene.add game object to scene, the new object that we just created, and then we're going to offset it a little bit so that's not directly on top of the old object. So we'll say new object dot transform dot position dot add, and then we'll just say 0.1 0.1, which will basically just add a tiny little offset so that's not directly on top of it. And we'll say this dot properties window dot set active game object to that new object, and then we will return. So now if we were to do this, then we should be able to copy once we implement this copy function. So let's go into game object, scroll down, and let's create a very quick and dirty copy object. So we'll say game object copy. And I don't like the way we're going to do this, but we're going to do it nonetheless. And we're going to put a to do in here. Come up with cleaner solution because it's ugly, but it works. And that's how we'll use it for now. Let's go into scene. If we go into scene, we already have a way to serialize and deserialize, which is basically creating copies of objects. So if we copy this code right here to create a JSON object and paste it right here, I'm just going to get rid of pretty printing because that really doesn't matter. Then we're going to go ahead and say string obj as JSON equals JSON.toJSON, and then we're going to pass it this, which is the game object. So basically this is going to serialize the game object into a string, which is right here. Then we will try and deserialize this string. So then we'll say game object obj equals JSON.fromJSON, and then we're going to say the object as JSON as the string we want to deserialize, and then we'll say game object.class is the class that we're using. And then we just have to do a couple things. First, we have to say obj.generate UID. So generate a unique ID for this game object, which we will create a function right here. Public void generate UID this.uid equals ID counter plus plus. This will just generate a new unique ID for this game object. And then we'll go ahead and say for each component, C in obj.getAllComponents, C.generate ID. So we generate new IDs for all the components. Then we'll say sprite render, sprite equals obj.getComponent, sprite render.class. If they have a sprite render, so if sprite render is not null and sprite.getTexture is not null, then we just want to make sure to reset the texture to the appropriate object reference, which we can do by saying sprite.setTexture. Asset pool.getTexture, and then we want to say sprite.getTexture.getFilePath. This will just make sure that we reset that object reference that's pointing to the correct object, and then we'll just return that obj. Okay, so now if we go into our game and we go ahead and duplicate this, we can duplicate it and it has all the same properties as that object. So now if we were to put this here, It should have all the same physics applied, which it does. Very cool, quick and dirty, but it works. Last thing I want to add too is if we go into Gizmo, and once again, we're gonna have to change this in the future, but for now it works. We'll say else if key listener dot key begin press, glif w key delete. So if they press the delete key while selecting an object, we want to delete that object. So we will just we'll just say active game object dot destroy. We destroy the game object. We'll say this dot set inactive. We are no longer using the gizmos, and then we'll say this dot properties window dot set active game object to null, and then we'll return. That should allow us to delete objects as well as add objects. So if we click this and we hit delete, we can remove it from our game object scene, and we can click this and hit duplicate an object, and we can do that, which is pretty cool. And then we can duplicate this one too, drop all these, and it works like you would expect. This is really cool stuff. I think so, at least. Maybe you guys don't, but we have physics working, and we can sort of start building scenes pretty easily. Now, there is one more thing too that I do want to address. If we drag and drop one of these guys in, and we were to move him over this and change his Z-index, if we change it to like -3, it doesn't do anything right away, but if we play stop, you'll notice then it changes. We should change this so that it changes immediately, because that's not cool. Basically what's wrong is the Z-index is being changed, but it doesn't take effect until the next time we add it to the render. So to fix this, we can just go into our render batch and just add a couple things. This is also kind of dirty. Don't like the way this is done. We'll fix this in the future. So we'll say to do get better solution for this. Basically what we're going to do is we're going to say if sprite.readd, which means that we need to re-add it to the render, which the only reason we would need to do this is because the sprite has changed its Z-index, right? Actually, no. Okay, so let's do this. We'll say if sprite dot game object dot Z-index dot transform dot Z-index does not equal this dot Z-index. So if we have a sprite in here that isn't actually supposed to be in here, what we're going to do is we're going to say destroy if exists sprite.gameObject, which clearly it does exist. What does this do? Remember, this basically just shifts all the sprites over it. So what we want to do is we want to make sure that right after we destroy it, wherever that just happened, right here, we want to make sure to say I minus minus, that way we don't skip any sprites. And then we want to re-add this game object to the render. So then we should be able to just say render dot add game object, and then we'll say sprite dot game object. And the way we can do this is very simply by getting a reference to our render. So inside of this constructor, we'll say render, and then we will keep a reference to that render right here. And then we'll just say this dot render equals render, and if we run this, we'll get an error because we need to add that right here now. So then if we go move this to a new line, and if we pass this, which is the render, so this is inside the render class, if we pass this, we will pass the render. And then this is saying this isn't a function, so if we just say add, that should add it to the render. Okay, so now if we click this and we say transform, change the Z-index, and we get an error. What is that error? Concurrent modification. So if we click into here, we can fix this pretty simply just by saying for int I equals 0 until I is less than batches.size, I plus plus. And then we'll say batch or render batch equals batches.get I. If we do this again, we should be good now. So then if we go ahead and move this, okay, cool. Now we can change the Z-index. Awesome. And then if we change this to an even higher one, it goes in front of that. Cool. Okay. So that was something else that I thought was just important that we should have in there right now. Now I can't remember if I am forgetting anything, but I think this is it for this tutorial. We've done quite a bit, and it's pretty cool seeing what we can do now. We can build physics simulations and scenes, and it works pretty good. I think in the next tutorial, what we're going to start doing is actually start building a game, because the engine is at a point where we need to. We still have some problems, like you'll notice the grid lines aren't really perfect. We need to fix that. And there's some other things that we need to fix. But I feel like for the most part, the engine is at a good point to start building the game. And as we build the game, we'll see the features that we actually need. Anyways, I hope you guys enjoyed this. If you did, please hit like and subscribe. And I'll see you in the next tutorial when we start creating our first player script or something like that. All right, guys, see ya.